So while the video was rendering, we did a little extra work here. So we filled in the chart for g of x, we plotted the points, we drew the line. Feel free to pause if you need. Next, the vertical line test. If any vertical line touches a graph more than once, that graph does not represent a function. Why not? Right, because there would be an element in the domain that would have multiple elements in the range that it would map to if a vertical line touches the graph more than once. The domain would repeat. So, let's briefly use the vertical line test. Is that a function based on the vertical line test? No. How about that? Yes. 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 You need me to scroll a little bit? Oops. Shoot. I hate it when I do that. How about now? No. All right. Recall that arrows mean that the graph extends infinitely in that particular direction. A closed dot is an endpoint, and an open dot is air quotes. This so because people can't see what I'm doing, I have to mention that. And so an open dot is an air quotes endpoint. It's like it's where the graph stops, but the point actually isn't there because it's open. The next thing I'm supposed to do is show example 7 on page 206. So if you're watching this video, you might want to log into Course Compass, go to the textbook, and look at example 7 on page 206, because you're not going to be able to see it on the screen. All right. So let's zoom in. The human immunodeficiency virus, or HIV, infects and kills helper T cells because the T cells stimulate the immune system to produce antibodies. Their destruction disables the body's defenses against other pathogens. By counting the number of T cells that remain active in the body, the progression of HIV can be monitored. The fewer helper T cells, the more advanced the disease. This figure shows a graph that is used to monitor the average progression of disease. The average number of T cells, f of x, is a function of time after infection, x. Why does this graph represent a function? There's a very simple answer. Huh? Okay, so that could be more specifically said using a little bit more technical language. What were we doing here?
Line test.
What kind of line test?
Vertical line test.
There. Yeah, we need to be more precise here. So yes, this graph passes the vertical line test, therefore it must be a function. Use the graph to find f of 8. How would you find f of 8? Nobody. No one has a clue how to find f of 8. This right here, using a graph. Take a guess. Like if somebody walked up to you on the street and held a gun to your head and said, how do you find f of 8 on this graph? And your answer, I mean, you got to answer because you don't want to die. What would you say? Say what? Yeah, so look at 8 and then see where the graph is at 8. It's right there, which would be at 200. So f of 8 is 200. For what value of x is f of x equal to 350? So this time I want to figure out what x corresponds with an output of 350. How would I do that? Yeah, so if I look at 350 on the y-axis and I follow it over until I hit the graph, that looks like that's at 6. So that'd be 6 years. What's the general trend of this graph? Negative. It's heading downward. With the exception of this little piece right here, the overall trend is a negative one. All right. Now, let's see how much time I have left on this video. Oh, plenty. So, we can get domain and range from a graph. We're going to do lots of examples. So, let's say that's the graph of my function. Basically, if I look at all the possible x values for this function, which would be from there to there, this set right here would be my domain. So from left to right. And then to get the range, you would go from the lowest point to the highest point. Now notice that that's not necessarily where the endpoints are. It's just the lowest point on the graph to the highest point on the graph. All right. So let's do some examples of this. We good to go on to the next page? All right. We shall call this graph F. So you got -2, 0, 0, 1, and 1, 3 is the key points there. So what's its domain? By the way, this is the shorthand I like to use for the domain of F. It's not official math abbreviation stuff, so if you try to use it in somebody else's class, they're not going to know what you're talking about. But that's what I like to use for the domain of F. So what's the domain of F? -2 to 1. We can do that as an interval, right? Brackets because the endpoints are closed. -2 is the leftmost point, 1 is the rightmost point, and everything in between. So what's the range of F? Zero to 3. The lowest it goes is 0, the highest it goes is 3, and it includes everything in between. This next graph is going to be called G. Somebody else want to give me the domain of G? How about -3? That's all right. Looks good to me, parentheses, because that left point is open. And the range? 1 to 2. Are there any questions over how to come up with that? I'm going to let this video render, and then we'll finish.